A very good morning to all of you. I cordially welcome you all for this applied thermodynamics course. So today we are going to discuss about the CDT number 2, that is how can we use the steam tables as well as the Mollier diagram to calculate the steam properties. So the motivation here is it is very essential to know the find out the properties of the steam from the steam tables as well as the Mollier chart to find the performance of the thermal power plant. So here, how can we find out the steam properties from the steam tables as well as from the Mollier chart? It is very important class. So the outcome of this particular lecture is you should be in a position to evaluate the properties of the steam from the steam tables and from the Mollier chart to find the performance of a thermal power plant under the given conditions. So here I already told you that basically here we are having the wet steam as well as the dry steam as well as the superheated steam. The steam tables are basically categorized into two types. The first one is basically known as the pressure tables and the second one is known as is the temperature tables. So here you can see it is the following two tables. So the first one is known as the pressure table and the second one is known as the temperature table. So how can we find out the various properties of the steam from the steam tables? So just here I have given you one example. So let us say it is a pressure base table. So it is the table 7.1. It is brackets we have written is a pressure. That is the pressure based steam table. So that is how can you say that it is a pressure based steam table? Here is that in the first column you are able to see the absolute pressure P in terms of the bar. So whenever in the first column the pressure parameter is there, then it is a pressure based steam tables. If the temperature is there in this particular the first column, then it is known as the temperature based steam tables. So now you can see in the first column you are able to have the absolute pressure. The second one, what is the corresponding saturation temperature at this particular the absolute pressure value? And the third column, we are able to have the specific value of the steam. So that is for wet steam as well as for the dry steam. And similarly, the specific enthalpy, that is the HF, that is the enthalpy of the liquid steam, enthalpy of the dry saturated steam, HG. It is the latent heat of the vaporization, HFG. It is always equivalent to Hg minus HF. And the specific entropy, similar to the enthalpy, is the entropy of the liquid steam, entropy of the dry saturated steam, and it is Sg minus Sf is equivalent to Sfg. So that is whether it is the pressure based table or temperature based table. So always our intention is to find out the three important properties of the steam. One is the specific value, specific enthalpy, and specific entropy. Now let us see one example. So if the steam is available at 0.01 bar, so at 0.01 bar, what is the corresponding saturation temperature? It is 6.983 degrees centigrade. And Vf, specific value of the water, it is equal to so and so meter cube per kg. Vg, so and so. HF, HFG, HG, SF, SFG, SG. And if the pressure is varies from 0.01 to some zero point 0.2, so at zero point 0.2, just you have to note down that is at 0.2 bar pressure, what are the corresponding properties of the steam? So these are the corresponding properties of the steam. So that we are able to get it from the steam tables. That is what is the value of the HF at 0.2 bar. So simply just you have to go to the HF table at 0.2 bar. So it is 251.5 kilojoules per kg. And what is the SG value at 0.2 bar? SG value is nothing but 7.909 kilojoules per kg Kelvin. So like that we are able to know the properties of the steam from the steam tables. It is very easier one. So now let us go to the temperature basis. So I've already told you that whenever you are having the temperature based steam tables, in the first column you are able to have the temperature parameter, and for the given temperature what is the corresponding saturation pressure value, and the remaining all the three columns will be remain as it is. There is no change. Specific value, specific enthalpy, and specific entropy. So here you can see the at 0 degree centigrade what is the corresponding pressure, and similarly the all other the specific value, enthalpy, and entropy values from this particular temperature basis steam tables. So here you can see it is known as the Mollier chart. The Mollier chart is nothing but it is the HS diagram. HS diagram is nothing but enthalpy versus entropy. So enthalpy always will be taken on y-axis and entropy will be taken on x-axis. So it is the HS diagram, enthalpy versus entropy diagram. So here the red line is basically representing it is the saturation line. So on this particular saturation line we are able to have, so this is the saturation line. So you know that saturation line is nothing but x value is equivalent to 1, and below this particular one we are able to have the various dryness fraction of the steam. That is, here you can see if the x value is equivalent to 0.65, 0.775, 0.885, 0.95 and 1. So that like this the dryness fraction values are progressively increasing towards in this particular direction, and x value will be equivalent to 1 on this particular saturation line. And similarly here, how can we plot the constant pressure lines on the Mollier diagram? Now here you can see it is a 0.01 bar, is the blue lines. So all these particular the blue lines are basically representing it's a 0.01 bar, 0.02, 0.03, 0.011, 0.2, 0.51 like this. And now similarly here you can see it's the green lines. So these green lines are representing the constant temperature lines. So here it is the 650 degrees centigrade, and here the constant pressure line, here is the constant pressure line is equivalent to 2, and here it is a 450 degrees centigrade. So at this particular point here you can find out at a 2 bar pressure at 450 degrees centigrade temperature, so what is the corresponding entropy value? By plotting a vertical line here you can find out it as 8.4 kilojoules per kg Kelvin, and similarly by plotting the horizontal line here, so here you can say it is equal to approximately some 3450 kilojoules per kg. So like that we can find out minimum two properties. If you know, then you can assess the remaining properties of the steam very comfortably from the Mollier chart, which is nothing but the HS diagram, that is the enthalpy versus entropy diagram. So like this, so the same diagram can also be represented like this. So it is the critical point. I told you that at the critical point the latent heat of vaporization value will be equivalent to 0. So these are the constant pressure lines and these are the constant temperature lines. So it is a representation of the HS diagram or the Mollier diagram. So here just I am giving you one problem, that is how can we use the steam tables as well as the Mollier chart so to find out the various properties. So please go through that particular problem. So here he has given that pressure is equivalent to 10 bar and the temperature is given as 200 degrees centigrade. So just you go to the steam table because he has given that the specific value is equivalent to 0.175 meter cube per kg. So go to the steam tables at a temperature of 200 degrees centigrade. So at a 10 bar and at a 200 degrees centigrade. So just you find out what is the Vg value, and similarly the other values, that is the corresponding saturation temperature, and similarly the enthalpy as well as the specific value. So here the at a 10 bar the saturation temperature value is nothing but 179.9 degrees centigrade, but he has given the temperature value is equal to 200 degrees centigrade. So that is the T given temperature value is greater than the T saturated. So automatically it is nothing but the given condition of the steam is nothing but the superheated steam. The superheated steam value is given. So that's why what is the degree of the superheat? It is nothing but T superheated minus T saturated. So T superheated is given as the 200. T saturated from the steam tables we are able to find it out is as 178.9. So the degree of the superheat is equivalent to 20.1 degrees centigrade. Next, condition of the steam at a value 0.175 meter cube per kg. So here the Vg value at the given pressure value is equivalent to 0.194 bar, 194 meter cube per kg. But the given value is nothing but 0.175. That is here the V given here the V given value is lesser than the Vg, that is a dry saturated steam specific value. So automatically we are able to say that so this particular steam is given as the wet steam. If it is greater, it is the superheated. If it is less than, it is a wet steam. If it is equal, it is a dry saturated steam. So these are the simple things always we have to remember. So whenever it is wet steam, so automatically our intention is to find out what is the dryness fraction of the steam. So the dryness fraction of the steam, so here you are able to assess the 0.175, it is a given steam specific value divided by 0.194, that is a dry saturated steam, the specific value. So that we are able to find it as the dryness fraction of the steam is equivalent to 0.9, so that we are able to say that it is equivalent to wet steam, and the first condition is the superheated steam. So here the second problem here also you can see. So here he is asking about the drop in the enthalpy of the steam. So he has given that 12 bar pressure, the degree of superheat is given as the 67 degrees centigrade, and at the pressure P2 is equivalent to 1.15 bar, and the dryness fraction value is given as the 0.95. So first of all, at 12 bar from the steam tables you find out what is the value of the HF and what is the value of the HFG as well as the HG. And he has clearly given that it is a superheated steam. And just you go through the important formula of the superheated steam enthalpy, that is the H superheated is equivalent to Hg plus Cp into T superheated minus T saturated. So since the Cp value is not given, so just we are taking the Cp value is equivalent to 2 kilojoules per kg Kelvin. So just you substitute all the values, we are able to find out the enthalpy of the superheated steam is equivalent to 2916.7 kilojoules per kg. And similarly go to the next condition of the pressure, that is equivalent to 0.15 bar. At 0.15 bar also you note down what is the value of the HF as well as the HFG, but he has clearly given that it is the wet steam because the dryness fraction is equivalent to 0.95. So just you use the enthalpy of the wet steam, H is equivalent to HF plus X into HFG, substitute X value, and here we are able to find out, so this is the H1 value, and let us say it is equivalent to H2. So drop in enthalpy of the steam, it is nothing but H1 minus H2. We are able to get 805.7 kilojoules per kg. So like that we are able to solve some important problems based upon the steam tables as well as the Mollier chart. So now I have given you some important objective type of the questions which are given in the previous GATE and IES examinations. So please go through this particular one because all the theoretical concept is already discussed in our CDTs. Now based on this particular CDT, now you should be in a position to answer this objective type of the questions. So I have given you the important objective type of the questions based on this particular CDT. So now just you keep your answers aside and now you check whether you did the correct answers or not from this particular one. So just you match your answers with the correct answers now, and now you can assess on your own whether how many questions have you done correctly or not. If your performance is more than 6 or 60 percentage, so it is good. Otherwise you have to improve a lot. So you have to listen the CDT lecture once again, and you have to listen the concepts very carefully to answer such important questions based on this important CDT number 2. So thank you one and all for listening this important lecture on the CDT 2. So we will meet you next in the next class. Thank you.